Hey folks, Mr. Dell here. We are looking at a problem, a couple problems here, examples of finding unit rates and what that process is and what a unit rate is. So this is coming from CPM's course 2, and this is section 9.2.4, number 9-92. It says, this problem is a checkpoint for unit rates and proportions. Checkpoint 9. In parts A and B, compute the unit rate. In parts C and D, solve the proportions. So we're going to talk about proportions, solving proportions, as well as finding unit rates. Okay. So the process here. So we'll do this A. Tina drove 108 miles and used 4.5 gallons of gasoline. When you're given a situation with two units, right? And you're comparing those two units. So in other words, we have 108 miles and 4.5 gallons of gas, right? So those things together create a ratio. I can create a ratio. I'm going to say 108 miles for every 4.5 gallons of gas, right? So that's my ratio here. A ratio is a comparison of two units. Two numbers. So 108 miles for every 4.5 gallons. So it asks now for the unit rate of miles per 1 gallon, right? So miles per gallon is a unit rate. So what I want to do is I need to figure out what math I can do to this fraction to get 1 gallon in the denominator, right? That's the process of creating a unit rate. So what does that look like? So this is a fraction, right? Fractions, what can you do? You can divide and multiply by giant ones. So in this case, I'm going to divide by 4.5 because 4.5 divided by 4.5 is 1. So I'm also going to divide by 4.5 here, right? So I'm dividing each top and bottom by 4.5. That's that giant 1. So 4.5 divided by 4.5 is 1. So now I've just got to do the math on 108 divided by 4.5. Okay, so you can do that on the side, or in this case, if you have a calculator to use it, you can use a calculator to do that division. So 4.5. So you get an answer of 24. So that right there is my unit rate. 24 miles for 1 gallon. So we can rewrite it as 24 miles per gallon. That's that unit rate of miles per gallon. Miles per gallon, MPG. All right. B, it says if 17 oranges cost $3.23, compute the cost per orange. So I want, and I'm going to look at I should have done that up here, knowing that I was going to have miles per gallon. I wanted my gallons in my denominator, right? So that just kind of worked out for me. But here I'm looking at oranges cost that much money. So what I want for my unit rate is cost per orange. So this is telling me I need cost per orange, right? Cost on the top, oranges on the bottom. So if I'm going to start with the information I have here, I can create a ratio first. The ratio I'm going to create, and I'm wanting cost. So I want my money on top. So I know it's $3.23 for 17 oranges. So that's a ratio. That's a comparison. $3.23, 17 oranges. So what do I want? I want it per 1 orange, right? I want 1 orange on the bottom. So once again, I'm going to look to see how do I convert this to have 1 orange. That's my unit rate per orange. Well, to get a 17 to be a 1, you divide by 17. And that's what we can do. We can either divide or multiply by the same number, top and bottom of a fraction. So I have to take $3.23 and divide by 17. And I get 19 cents. So 0.19 or 19 cents. So again, that's my unit rate. 19 cents per orange. Right? 19 cents per orange is my unit rate. Okay. Put a box around these actually as I finish them up. All right, so that's finding unit rate. So now let's talk about solving proportions. If I have a proportion, I'm looking for my x. I'm trying to solve for x. There's a few ways to do this, but I tend to like to look at it as when I'm solving an equation, my goal is to get 1x, right, to get x isolated. So what we do when we try to isolate x's in our solving equations is we use inverse operations, right? What can I do here? What math can I do to make that x divided by 12 become just a 1x? So if I have x divided by 12, how do I become 1x? Is I can multiply, I'm going to show it down here, by 12 over 1, right? Because think about what we have. 12 over 1 times x over 12. Well, the 12s actually cancel. You can look at it that way. The 12s cancel. Or if you just multiplied straight across, you'd have 12x over 12, which 12 over 12, sure enough, is 1x, is what I wanted. That's how you isolate the x. So I multiply by 12 over 1 to make the x then just 1x. So to do this legally, though, all right, on any equation, if you're gonna do one thing to one side, you always do it to the other side as well. So I'm going to multiply 20 over 30 times 12 over 1 as well. So here, again, I can look and I can simplify first, or I can just multiply straight across. 20 times 12 is 240. 30 times 1 is 30. And then I can think about, oh, does 240 divided by 30? It sure does. Divides 8 times. So x is equal to 8. That's one method of this. So I'm going to just do the same looking at this problem here. We can look at it again the same way. I need my m all by itself. And what's happening over here, I'm going to rewrite it so I can show you the math. I have m divided by 100. M divided by 100, right? So m divided by 100, what do? You multiply by 100 over 1, because that causes those hundreds, 100 on top, 100 bottom, to cancel out, become a giant 1. So what you do to one side, you do to the other. One of the things, too, I didn't point out, we could do prior to multiplication. We could also simplify, cross simplify, right? I know that 10, a giant 10 divides into this. So I can divide by 10. 40 divided by 10 is 4. 100 divided by 10 is 10. So it just makes our number smaller. And then when I multiply it, I have 10 times 13 is 130 over 4. And then I can think about, well, does that divide even further? I believe I can simplify that even further. I can divide by 2, top and bottom. So that becomes 65 over 2. So m is equal to 65 over 2. Okay. All right, there we go.